Welcome to IDSKT. Let's explore an important topic shaping the future of defense and global security. I'm the founder and director of International Defense Security and Technology, a California-based nonprofit think tank dedicated to research and analysis on global defense, security, and emerging technologies. I also serve as CEO of Interplanix LLC, a New Mexico-based company advancing satellite risk analysis, orbital debris forecasting, and space security frameworks to ensure mission assurance and resilience. Previously, I served in leadership roles at India's Defense Research and Development Organization, DRDO. Most recently as Director of the Systems Analysis, Modeling, Safety, and Quality Cluster at DRDO Headquarters, New Delhi. This channel brings you deep insights into the global security ecosystem, from geopolitics and emerging military technologies to cyber, space, and system-level analysis of tech trends and their interrelationships. Subscribe and join us as we decode the forces shaping the future of global defense and human security.
Today we are diving into a revolution that's unfolding just beyond our atmosphere. We've all heard about factories on Earth. But what if the most valuable factories of the future aren't even on this planet? Imagine manufacturing ultra-pure semiconductors, cutting-edge cancer treatments, or even synthetic human organs in the weightlessness of space. Sounds like science fiction. It's closer to reality than you might think. The only thing holding us back: getting those goods back to Earth. You see, launching materials into space is now almost routine. But bringing things back safely, affordably, and at scale, that's the real bottleneck. Traditional cargo return systems are stuck in the past. Most still rely on capsule technology from the Apollo era, bulky, expensive, and wildly inefficient. Want to bring back just 1 kilogram of material on a Dragon capsule? That'll set you back about 200,000. And only a tiny fraction of that payload is usable cargo. For industries hoping to make space manufacturing commercially viable, this model doesn't cut it. Even pharmaceutical giants like Merck have spent millions returning a single crystal from the International Space Station. It's unsustainable. But change is coming, and it's coming fast. Leading the charge is a startup called Outpost. Their radical new reentry vehicle called Carriel is poised to rewrite the rules. Think of it as space's version of a shipping container. Modular, compact, and built for scale. Carriel uses a 3-phase return system: autonomous orbital departure, next general thermal protection, and finally here's the real twist: a robotic paraglider assisted landing. That last bit, it's not just for show. The paraglider enables pinpoint landings within 10 meters of a target, even in nasty crosswinds. That's a game changer for biotech cargo that needs rapid, safe recovery. And it gets better. Outpost's carbon fiber heat shield, reinforced with silicon carbide nanotubes, doesn't burn up on re-entry. That means it can be reused multiple times, cutting costs even further. Combined with AI navigation and high-efficiency propulsion, Carriel delivers a 50% payload-to-mass ratio. That's 5 times more efficient than what we use today. The result: return costs drop from 200,000 per kilogram to as low as 1,200. That's a 90% cost reduction. And companies are already lining up. Biotech firms like Synthia Bio are planning missions to return lab-grown retina cells. Industrial players want to bring back flawless turbine blades made in zero gravity. But Outpost isn't alone. UK-based Space Forge is working on ultra-pure metal alloys with weekly return flights. Varda Space Industries is focusing on high-purity drug crystals. And Sierra Space's Dream Chaser spaceplane is targeting gentle runway landings for delicate cargo. All of this is unlocking a 500 billion opportunity. In orbit, you can grow protein crystals 10 times purer than on Earth, revolutionizing cancer treatment. You can 3D print human organs without gravity-induced distortion. You can produce exotic alloys that make jet engines lighter and stronger. Even fiber optics like splin, impossible to perfect on Earth, come out flawless in microgravity. But none of it matters if we can't bring the results back home reliably. That's why 2024 through 2026 is the make or break phase. Outpost plans its first full-scale recovery in 2026. Varda is aiming for 12 missions by next year, working toward FDA approval for space-made drugs. By 2030, we might see entire factories operating off-planet. Orbiting warehouses could store, process, and ship materials straight back to Earth on demand. Think Amazon Prime except from space. Of course, there are hurdles. Regulators need to catch up. Today's reentry rules weren't made for daily space flights. And then there's traffic management. With thousands of return vehicles expected each year by 2035, avoiding collisions will require AI-powered coordination. Public trust is another challenge. Safety must be front and center because when people hear returning from space they worry about fireballs in the sky or crashes in their backyard. Companies need to prove these systems work flawlessly and transparently. But if we get this right, we are not just opening a return lane. We're opening the door to a new era of human industry, one that starts in space and ends in your hands. The dream of in-space manufacturing is no longer about what's possible. It's about building the road home.